Welcome to Making Awesome, episode 8, if I'm counting correctly. Today's topic is what is 3D printing? Because stupidly, I recorded this episode many moons ago, and it was a solo episode. And I not only forgot to upload it, but I forgot to re-record it with everybody else. So I am Grant. We've got Tad and Thomas here. We got the boys. We're hanging out. Let's talk about 3D printing. Now, this is a little interesting because Thomas has almost no experience with 3D printing. Tad has a little bit, and I've got more than the two of them. So we're going to start. Thomas, I want you to tell us what your idea of 3D printing is. What is 3D printing to you?
Oh, man. I'm going to go with my very first instinct, which is I can take a 3D model that I have on a computer, and then I can make a machine print it in real life using material.
But how does that work?
Hot plastic. It's like a hot glue gun on like a robot arm.
Are you remembering the things that I've told you about this?
This is exactly what I've always thought about it, because that's like what it is, right? It's like a hot, because they have those pens that they came out with a while ago that was like they were sold as like a
pen.
Can you believe that you can like draw something in 3D, and they're very difficult to use, but some people can like pull it off. And I looked at those and I was just like, okay, so that's just a hot glue gun, guys. Like, that's
look, I've relegated us to being that we're just going to be cussing through this, so it's okay.
Oh, okay.
Yeah, I've started marking all.
I'm trying not to.
Since you came on, I've had to start marking all the podcasts explicit, Thomas.
Oh, but I don't want that to be. We could always
potato.
We can just cut it.
I'm not.
If you really want.
Do you know how much editing I do to this?
0?
None.
It's the hey, done, upload it. And see, it's things like my phone is ringing right now. We're going to let that go. It's the company phone line, but oh well. We're recording, damn it. But okay, so you're describing a computer control. It's a robotic arm with a hot glue gun on it, right?
Yep.
So what you're actually describing is called a SCARA printer, and we're going to get into that.
Cool.
What else do you know about the 3D printing industry?
About the industry of 3D printing?
About the industry, because this is not, these hot plastic machines are not the only type out there, or is that the one you're most familiar with?
Well, I think it's the one I'm most familiar with, because it's like the most shown on like in popular media. However, I do know with my time working in aerospace that 3D printers are used at a much larger scale with a much different materials like hot metals and things. And crazy enough, Montana State University a while ago actually had a ceramics 3D printer, and we were able to 3D print pottery and then fire it. So, I feel like...
How accurate was that? Did it shrink like crazy?
Well, yeah, because of a firing process, but that's like known in ceramics. So the people doing it always had everything at a scale that they knew, all the whatever. But so I at least know that it's used probably in a bunch of ways that are like more of an industrial sense instead of just like like I printed the little weird pug bird that we printed, Tad and I, and
do you have it?
Yeah, I do. I'll
show it off. Come on.
There he is. So we're not just like printing toys and things. It's
literally
kind of
holds up
like,
a toy.
Yeah, but the kind
show
of
us what you did to it.
Oh, should I? I don't know. I put a butthole on it.
Yeah. Well, now it's at SFW. All right, it's over. It's over.
But I kind of like I draw the comparison of like people see like screen printing as like a process that's like, oh, you make t-shirts with a screen print.
But
like,
you can do so much more.
But screen prints being used like in factories, that's where it started. Like it wasn't like a t-shirt printing thing at first. Like they printed the fronts of microwaves and like all sorts of different things that
clock
screen
faces
printing does. Yeah, like everything is screen printed, and people just didn't know. So I feel like that's where 3D printing is for me. Like I know what it is at a shallow level, but I'm sure it's being used on much larger industrial scales that I'm not familiar with.
Oh yeah. All right, Tad, your turn. Talk to us.
3D printing at its heart is additive manufacturing, as opposed to like conventional subtractive manufacturing where you have a block of whatever and you are removing material from it by cutting, milling, sawing, whatever. So with additive manufacturing, you're taking, just a blank empty space and you're adding layer by layer of material. And like Thomas was saying, I would say that most people are most familiar with filament deposition modeling, which is the plastic spool that goes through the hot glue gun type end, the hot end. Hi, Bailey. But there are other technologies out there. There's selective laser sintering. What's the other one? Resin printing. There's more than that. Grant, you know them all.
I know a lot of them. I
But
will
anyway,
never
yeah.
claim to know them all because I'm sure there's something that I'm missing.
You can get different effects and different levels of resolution with the different methods, but they all basically do the same thing. They add material.
Yeah, and that is kind of the core of it. And Tad, can you explain a little bit about your experience with types of 3D printing? You have a 3D printer now, so tell us a little bit about your experience with that too.
So you and I have FDM printers, and you have resin printers,
and I have sandstone and other stuff. Yeah, but yes,
you do. As we've discussed a little previously in some other episodes, I really got into 3D printing more in college because my school had a lab for that, and back then it was really shitty. It was not good at all. It was some kind of very cheap printers that went out of square all the time. Like you could never get the first layer to start properly. Yeah, I've pretty much only myself worked with FDM printers. I've had parts made on SLS printers. That's where you get it. It's like starts as like a white powder and it gets bound to each other, the layers, and then you get a nice little part. And the resolution of that is much better. So I use that for more finely detailed things.
Oh yeah, and it's normally PA6, PA66, or PA12, which are all blends of nylon. Mm-hmm. So it's also generally way stronger than anything that's coming out of FDM. Yeah. But to give the folks at home an idea here, the most affordable SLS printer that is functional that I am currently aware of is the Sinter at Lisa, or the it's gonna lose me right as I'm thinking about it. There's another cheap SLS printer. They're right at about 10 G's each. And so 10 grand, that's a lot of printer. Now, don't get me wrong. There is enough money on the wall behind me for an SLS printer, but not many. That's the thing. And these are really tiny. So I believe the Sinter at Lisa is like a 100 millimeter cubed build volume, which is less than 4 inches in every direction. And sure, if you're making small parts, that you will greatly, very quickly get that back.
But the commercial ones are like the size of a copy machine.
The commercial ones are bigger than that. And they start, so the EOS Formaggio P110, that's the kind of the best one price per performance that I'm aware of. They're about $110,000. I don't know what their build volume is off the top of my head, but they will produce parts that look freaking gorgeous. That's what a lot of SLS is made on, the P110. There are some larger, like the P280s, the P480s, and all that just has to do with build volume and laser size, because like Tad was saying, those are selective laser sintering. They call it a cake, but it's a big thing full of nylon powder that is heated. It is heated to very close to the glass transition temperature of nylon. And then you just hit it with a fiber laser. Since fiber lasers can put a ton of energy into something very quickly, you can bring that nylon wherever that laser hits above its glass transition temperature, and boom,
it binds.
You got it.
Yeah.
So Tad obviously has the most experience out of Tad and Thomas.
Mm-hmm.
But I've been in the industry longer than I think a lot of, I don't know. I think I've been in it longer than maybe Tad, maybe since, when did you realize 3D printing was a thing? I'm curious to see if I've been in it longer than you knew it.
Probably around 2010, but I didn't really do much with it.
Okay. So I've been in it a little bit longer than that. I started kind of late 2008, early 2009 with the Rep Rat project, built a Mendel 90. Mendel 9001, because, you know, the naming scheme has to be memes. And they were terrible. They were absolutely terrible. They were all FDM 3D printers. My first big machines were all FDM. Can I see it in the frame? No, I guess not. My first 3D printer is, I still have it. My first like commercially available 3D printer, but 3D printing, like Tad said, is all about additive manufacturing. With subtractive, you start with like a block of aluminum, you end with a part. With additive manufacturing, you start with a powdered material or a filament or a liquid, and you grow something. You have little to no waste. In some cases, you need a support material, but that support material is generally less weight than the actual part. When you look at a CNC milled part, you can lose 80% of its weight. And that's a big deal because
just chips.
Yeah, just in chips alone. Correct. You know, so it comes down to the different types of tech. So, you know, Thomas mentioned FDM, and he was talking about what's called a Scara arm. Scara arms are an old school style of 3D printing. They came about from old tape robots, so VHS and other like beta tape robots that would move tapes throughout a system. So they had one long column, they had an arm, and the arm would have multiple pivots. It would have like an elbow pivot and a wrist pivot, and it would have a shoulder pivot. So it could move like this, right? So its motion was completely linear. It could not move up and down. The entire arm needed to move up and down. Now we have, you know, like KUKA arms that have 6 degrees of freedom, so they're able to move it fluidly. But Scaras were really nice because they were incredibly rigid, and they were able to reproduce the same thing over and over and over again. The problem with Scaras, when you're moving a beta or a VHS tape, it's Betamax for those not in the know, you could not go very fast. Your goal was to move slow, but efficiently.
Yeah.
So their acceleration is extremely limited because their motors don't have a ton of torque. So for 3D printing applications, Scara arms are great because they're easily able to be made as tall as you want. But the bigger arm that you have, the better chance you have of it sagging. So
under its own weight.
Right. And so Cartesian printers, which if you are watching us on YouTube, you can actually see a couple of Cartesian printers running behind me. We should have had a couple more running, but I didn't get to starting them for this. There are 3 resin printers running, although I can see one of them is already done, so we'll call it 2. But I am sitting in 3D Musketeers Central. So 3D Musketeers is a supporter of this podcast, and I guess our main sponsor, because I'm paying for everyone else to be here. So damn it, I get to say that 3D Musketeers is paying for it. And Thomas, you're still muted for reference. I don't know why, but are you one of those guys that mutes themselves when they're not talking so you can be Mr. Professional?
I just figured that I didn't want to make a bunch of like, I don't know. I didn't want to shuffle around and make a bunch of noise.
Dude, don't worry about it. You got a great microphone. So for all of you audio only, you might have noticed the quality has changed just a little bit. My mic is still the same. Tad now has an identical microphone to mine. He has a Samson Q2U. And Thomas, what are you using?
It's an AKG P220.
Very nice. I don't want to get too deep into microphone talk, but
yeah, I could do that another time.
Worth it. It was worth every penny to get Tad a new mic. And we might actually have a guest coming in. Tad's dog happens to be hanging out in the background. Her name is Bailey.
This is Bailey.
Just gonna we can show her. She's a little wheezy.
She's sad for some reason that I can't comprehend.
Nobody loves that dog. That dog.
I know she doesn't have a friend in the world. You know.
No. For all of you, that's a joke. Please don't call anybody. We don't need that kind of crap.
No.
Anyways, let me get more into 3D printing. We're getting off topic. So at FDM, yes, they're computer controlled hot glue guns. Duct tape a hot glue gun to an etch a sketch. Bingo, bango, Bob's your auntie. You've got yourself a 3D printer. What?
That's such a good image. I just like
duct tape a hot glue gun to an etch a sketch.
Yeah,
because they actually work the same way, because one knob moves it in one axis, the other knob moves it in the other axis. For these machines, you have one motor for the X, one motor for the Y, sometimes one for the Z, but a lot of times it's two motors for the Z axis. And so, yeah, and when I tell that to people, instant recognition, they know precisely what we're talking about. And that helps because this tech is a little bit weird, right? People don't always understand it. And weird is scary, and scary doesn't mean good for business.
What's that quote? It's eventually technology will become
indistinguishable from magic.
Indistinguishable from magic. It's kind of the idea of, when 3D printing, I remember, first became like a known thing among like, normal people. I think everyone kind of freaked out because they're like, wait, like this was stuff that we like had, in Star Trek, and also we made fun of in cartoons as like the future. Just like kind of like more
you'll
realistic
be able to
VR.
make your own food.
Yeah, stuff like that. But
which I guess that's an offhanded Cloudy with a Chance of Meatballs reference. Absolutely phenomenal movie. Both of them were very good. A great kind of mad scientist style movie that is great with kids. Anyways, so we have FDM, we have SLA, which then there's also MSLA and DLP. Those three fit in the category of photopolymer resins. Now, there is technically Polyjet that has some photopolymer, but we're going to ignore that for right now. SLA, MSLA, DLP. So SLA, stereolithography, MSLA, masked stereolithography, and DLP, digital light projection. So we'll start with DLP because it is the easiest one for people to understand, because it's literally a projector. It is a projector underneath a piece of glass. Then there is a vat full of photopolymer resin. And similar to how old school projectors worked, where you would click in a new slide and boom, there's your image, that's what it would do too. But these are 1080p, 2K, 4K, 6K, and 8K projectors that are doing this. And obviously, the higher the resolution, the more resolution you get on your part. But the thing with projectors is that, of course, you can go really big. But your pixel density changes. So they're not popular anymore because, well, the cost of projectors is still pretty expensive. And even the micro projectors are still pretty expensive. Recently, I would say within 2 years, MSLA, masked stereolithography, has become kind of the new king of consumer grade 3D printing. Creality kind of owns that world of consumer grade 3D printing, but Elegoo, E-L-E-G-O-O, Elegoo, has kind of taken over the hobbyist resin printing side of things, because for less than $200, you can get a resin printer. And for someone that has spent $1,400 on most of theirs, getting one for less than $200 is ridiculous. Now, for those saying, well, I should just go out and get one myself, the photopolymer resin is incredibly toxic to humans. It will give you chemical burns. You can have major allergic reactions to it. And oh yeah, it absolutely stinks. It stains everything it touches. And it is exothermic. So when it cures under UV light, it gives off an ungodly amount of heat. So if I put like a drop on a table and hit it with a UV laser, it will smoke, because it is releasing a ton of energy that's kind of built up in it, right? It's potential to thermal energy.
You're saying something that could give me chemical burns, and if it's not well ventilated, it sounds like art school to me. It just like, I don't know.
Think about it. These are $200 machines that people are buying for their children, not understanding how dangerous this stuff is. Now, if you happen to have a resin printer that you're having problems with and you want to get rid of it, give us a call. We're always looking to buy printers at pennies on the dollar to get them off your hands. Because I've just told you how dangerous. If you don't believe me, go look up an SDS for one of those photopolymer resins. It is incredibly dangerous.
I'm looking at the Amazon listing for one now.
You shouldn't even put it down the drain. When you're done with cleaning it, because, oh yeah, by the way, you have to clean off all the excess resin. You should put that excess fluid, right, that fluid that's laden now with raw resin, out in the sun for a few hours before you can get rid of it. We do chemical waste. So we actually have a drum that we pour it into, and that it is collected routinely for chemical waste. because I don't want to go through all that BS because we're a business and we can do those things. But to give you an idea, if you're watching us, oh, and of course I have an auxiliary light, so now my arm is completely blown out. It's showing the printers in the background that are running. But the yellow and orange machines, kind of off to my, I'm hoping it's my right. It's my right in the real world. Those are mass stereolithography machines. So what occurred to make these so cheap is that screen technology got cheap. So underneath them is a UV light source. That UV light source is masked by an LCD screen. So where the LCD goes black, nothing goes through it. And where it's not blackening out, it can easily come through and cure a quick layer on the part. Recently, mono screens have come out. And so our normal resin layer times are 8 to 15 seconds. Now it's 2 to 4 seconds with mono screens. And once these machines when I start to run out of repair parts for them, we're going to get rid of them and bring in some mono printers because they are that much faster and speed matters for this kind of thing. And you lose no resolution. The screens allow more light to pass through and they last a lot longer because of it. The LCD screens on MSLA printers are a consumable. Every 200 to 300 hours, you will need to replace it. And new screens are like $30. Mono screens are like 60. So when you're spending $200 on your printer, but then you got to make sure you have a $30 replacement, well, hold on here. But let's get into some of the cleaning parts of it, right? For cleaning, you need either alcohol, which good luck getting that right now, or mean green. That's kind of been the one that everyone's moved to because it's non-volatile. You can buy it by the gallon. It's $5 a gallon at Walmart or Target or wherever you get your stuff from. And it works just as well. Well, there are now wash and cure stations because normally you'd have to use ultrasonic cleaners or wear gloves and use a toothbrush. It made a mess. Now with these wash cure stations, you're able to do all that much easier. Those wash cure stations run about $150. And if you're going to take this stuff seriously, let's say you want to do minis for your Warhammer 40K campaign or something like that, we highly, 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 highly recommend you get the wash cure station. It is absolutely worth the extra. So moving over to regular SLA, that is also done with a laser, similar to SLS, which is selective laser sintering. SLA, which is not selective laser additive, it's stereolithography. I don't know why it's called SLA. I'm sure there's a thing for that. If our writers, if you're listening to this, add that to the blog post. We'll send people to the blog post so they can find it out. So now you have to read the blog post. Because content is king these days. But SLA, most commonly people know it from Formlabs. Formlabs is the largest SLA printing company out there. They have the Form 2, the Form 3, the Form 3L, and the Form 3B right now as we're talking. Form 3B is bio, so it can do biomedical 3D printing, which is so cool. But oh my God, the resins are expensive. Formlabs and 3D Musketeers have a bit of a sordid past, so I'm going to give you the facts about their machines, and that is it. I'm not going to give my opinion on it. Formlabs makes SLA machines, so they use a laser source and what's called a galvanometer. Galvanometer is a pair of mirrors that are on servos that can move extremely accurately, repeatably, and incredibly fast. They use a UV laser that cures layers. Okay, so it goes around. There's Bailey. No, it's not. It's not a door that needs oil. Hey, Tad, have you tried oiling your dog?
I don't know. Bailey, would you like oil? Maybe we could squeeze you and get the oil out.
If it's tuna in oil, maybe.
Yeah.
Although, I don't know. Do dogs like tuna? I have a cat. My cat loves tuna.
I'm sure she would eat tuna.
I think dogs will pretty much eat just about anything. My dog eats just about anything. So,
what kind of a dog do you have?
He's a Shuscador retriever.
I don't know what that is.
It means he's just about so much mutt that it's indistinguishable what kind of dog he is. But we know there's husky and we know there's retriever. Yeah, so that's pretty much. And there's I think there's some Burmese in him as well. He's a cutie. He's not here right now, though.
That's okay. Victoria is not only my cat, But she is also our assistant to do meeting scheduling. So those of you that are listening to the podcast, you now know one of the hidden Easter eggs inside of 3D Musketeers. The digital assistant is also named Victoria. And those in the know that's the name of the cat. The cat is our current director of marketing. And anyone that we bring on for marketing, we let them know that your job is to work underneath the cat.
Yeah.
Because truly, honestly, she should be the CEO because, I mean, she runs my life. Wrapped around the finger. But anyways, Formlabs SLA printers, the big downside to using laser-based SLA is that it's slow. Because it can't expose the entire layer at once, it has to slowly move across that bed. However, a laser source is more powerful. So you get parts that are generally stronger out of a Formlabs machine, but they take longer to produce. Formlabs does beat all these cheap Chinese 3D printers in that their software is absolutely freaking amazing. It is a gorgeous piece of software. It's called Preform. And no, for all of you wondering, well, why can't I use that on my cheap printer? It's because Formlabs printers start at like $3.5 grand. That's why. Sorry, it's business. So they're good machines. They've got their own wash and cure station, although realistically, with how cheap wash and cure stations are for like Elegoo printers, I don't think I'd get the ones from Formlabs. Prusa Research also makes an MSLA printer. It's roughly the same as an Elegoo Mars, but it's much nicer. The build quality is nicer. We have quite a few of the Prusa SL1s in our shop. So let's move on to selective laser sintering and in turn DMLS, direct metal laser sintering, which is honestly one of the coolest types of 3D printing because you're literally using a laser to build things. Now, we have a laser cutter here at our shop, so we can use a laser cut through things, but building something with a laser is overtly freaking cool. Like Tad was saying, it is a powdered process. It is PA6, PA66, or PA12, which are nylon blends. And they make parts that are incredibly, incredibly strong. They can be weak in some directions, but as long as you are hitting it hard enough with the laser, the parts are relatively indistinguishable from an injection molded part in strength. SLA makes parts that are absolutely gorgeous. We call it high detail resin for a reason. It makes injection mold quality parts. SLS makes injection mold quality strength, but it does not make it look injection molded. Now you can tumble it, polish it, stain it, and everything like that to make it look a little bit nicer, but it will never look as nice as an injection mold. SLS machines are nice, but they can be very expensive. There are no hobbyist grade SLS machines, and for good reason. The lasers will cut through your hand and leave you like Luke Skywalker, and nobody wants that unless that's your thing. And we're not here to kink shame. That's not what we do around here. That's a company policy.
It's in the company policy.
It's not technically, but
not yet.
You know, if it's that, sure, it's an unwritten company policy. Okay. But you know, they're cool machines, and especially DMLS. If you have the opportunity, and if I remember, I'll put some in the description, some videos on direct metal laser sintering. It looks so cool. You're looking at a bed of powder, then all of a sudden, some of it sinks just a little bit, and it comes over like a wave because that's the laser heating up the metal powder and it's melting. It's freaking cool.
Dang.
I saw something recently, Grant. It was some rocket company making tanks for their rocket.
Yeah.
And I think they had like a Scara arm setup, but I don't know if they were using like wire as their.
It might have been like a MIG welder.
Yeah.
And then,
but
and
I
that's
mean, they
common.
were printing the tank. Just,
yeah, and
with the arm going up the pole.
Those might be Scara arms. They might be Kuka. If it has the ability to turn its wrist rather than just rotate it, it's likely more of a Kuka style, like robotic welder arm. And we've seen those. There are a couple of bridges over in the Netherlands that are made this way. Now, 3D Musketeers is based in Florida. It is unlikely we will ever see 3D printed structures here in Florida just due to wind ratings and everything because of hurricanes. I assume we're going to start seeing them out in the Midwest because it is very cheap to do it that way. And NASA is currently working on, it's an X Prize right now to build lunar and Mars-based homes for astronauts.
It didn't NASA came out like a little while ago probably like last year sometime, and they were talking about sending a rover or like a satellite that was a 3D printer
to pre-3D print it. Yes.
Yeah, to source material from either Mars or the moon, and then
Because
that
the good thing
is entirely insane.
If you don't need to carry your raw material, you've now increased what else you can carry. And so, yes, that's actually where I was going with this. And this leads us into the concrete style 3D printers, or ones that use some sort of regolith, otherwise known as lunar dust regolith.
Yeah. This is what I'm super curious about: concrete. And
you know what?
Other like materials.
Talk amongst yourselves. I'm gonna go get a piece that's concrete 3D printed. So talk amongst yourselves. I'm gonna go get a piece. I'll be back in like maybe a minute, as long as I don't fall and hurt myself, because
be careful.
For those people that don't know, I have 2 herniated discs and I walk like I'm drunk. I am not drunk by any stretch of the imagination. I just can't feel my legs a lot of the time.
Not drunk.
I'll be right back.
Herniated.
I'm gonna go. Yes, yeah, not drunk, herniated. I'm gonna go get a piece that was done on a concrete 3D printer.
Yeah.
So keep talking. There are people watching and listening to this.
Yep.
Yes. For the folks at home, concrete 3D printing is basically just everything we've been talking about, but at a larger scale. It's like a gantry that can move back and forth, and it's got a head that goes across the center, and it just has a hose that puts down a layer of concrete and can, trace out a layer and go up and up and up, and you build your structure that way. It probably works very much the same way that the clay 3D printer that Thomas was talking about works.
Yeah. You know what's insane to me after talking about this? I hadn't known about all of these like photosensitive materials that we're printing with basically projections and screens.
Yeah.
That's just like, it kind of put it together for me, because that's just printing layer by, it would be like exposing
it's just
screens,
doing repeatedly
screen prints. Yeah. That's just like, it makes so much sense.
It's the same thing.
Yeah.
Okay. So I'm back and I have 2 little samples. This was from a company called Millibot that told me to come to Orlando. This was years ago. Come to Orlando. We'd love to have you on our executive team. We want to show you our 3D printer that fits inside of a container and it prints out of a special material. It's not actually concrete, but the system is identical. And I want to show you something is why concrete 3D printing is pretty cool.
Oh, that's cool.
You see that structure and how there's all that air? So for those that are listening, audio only, this part looks kind of like peanut butter. Now my camera's not autofocusing. Now I'm
there
back.
We go.
It looks like peanut butter. It comes out of the machine and it looks like peanut butter. But as soon as you catalyze this particular material, it grows about 110%, and it's an exothermic reaction and it makes air. So it actually off gas, technically it's oxygen. But the oxygen creates bubbles throughout the material. That's what causes it to expand. And it leaves you with something that is incredibly insulating. So this material, and it's proprietary, I don't know the mix of it, but you can use it to insulate walls. So you can build a building with it, and the walls are pre-insulated. Concrete 3D printing, if you go to the 3D Musketeers website, I mean, at the time of this recording, which is today's recording, is spooky because we're recording on Halloween.
Wow.
And none of us are dressed up. Actually, no. I am actually dressed up as one of the scariest things ever. A small business owner. Or I could say I'm my identical twin brother, like I do many years. And people ask, what are you dressed up as? I have an identical twin brother. So dressed up as him. Done.
I have this scary little goblin clucking at me.
It's true. You do. Yes. She is ferocious, to say the least.
You want to go on the couch? Here, keep talking.
But yeah, concrete 3D printers, it looks like, have any of you ever seen like spray cheese? Spray cheese is a bad one. Freaking whipped cream in a can. That's how concrete 3D printers work. But instead of it being a pressurized vessel that pushes it through, it's just generally falling through with gravity or a pump. And as the concrete comes out, they need something to quickly cure it, or you can only do a couple of layers a day because of weight. So a lot of this concrete is incredibly quick cure and is mixed It comes in as a powder and water, and it's mixed in a mixing nozzle as it goes out through the device. And that allows it to cure relatively instantly. And yes, this is how we're going to be building stuff in space. Because if we can just send a lunar rover with a 3D printer that can print in regolith or whatever the hell you want to use, you can now build structures. And sure, those structures may not be perfect, but I promise you it's better than nothing.
Mm-hmm.
So that when astronauts get there, they have a place to get away from the elements, right? It doesn't have to be airtight yet. The astronauts will bring that crap with them and they can build that.
Mm-hmm.
But you need some place to park the lunar rover so it doesn't get destroyed by the sand, right? Curiosity. I mean, God, what a success that rover was. It was supposed to only be up for what, 16 months, and it lasted almost a decade.
Yeah.
It was ridiculous. Curiosity is honestly one of NASA's greatest accomplishments, in my opinion. They built something that was designed to last like 16 months, and it almost did an order of magnitude longer than they expected. Concrete 3D printing is really, really cool. I hope that we get to see more buildings built with it because it opens up a lot of possibilities.
Mm-hmm.
You can build a single family home in 48 hours. And because you're building it slowly and the concrete gets air in it, it's really heavily insulated. That's a really, really cool thing. I don't know how they do windows. I haven't really looked into that.
I think they leave like a gap.
I think they have to leave the gap and then
they
you
just
cut
like
it in.
throw 2x4s in it and print around it, you know, because you can't bridge. You cannot bridge with that, right?
I don't think you can.
I doubt it.
I would assume because concrete printers are not very fast, but their layer heights are measured in inches. These FDM 3D printers, because it is concrete printer is just an FDM printer without the heat. FDM is measured in tenths of a millimeter. So we normally print in 0.2 millimeter layers. For reference, a human hair is 0.1 millimeters thick. So we're printing 2 human hairs thick per layer.
Yeah. If
resin
I was going to do
printers
it,
are 50 microns, so half a human hair thick rather than 200 microns. The concrete printers are 1.5 to 2 inches thick, which is 50-ish millimeters thick. Big difference. So
I would just stop it at the layer right below the top of the door or window.
And I guess they
build
maybe
up some 2x4s.
Yeah,
and just print across it.
They put a bridging material in there so it can go across, because you don't want support material made out of concrete.
No, God, no. Never be able to get that out of there.
You know, and a lot of these, they're called BAMs, big area additive manufacturing. It's based in Ohio. Ohio's huge for additive manufacturing, which is why I will probably never live in Ohio, because that means there's lots of competition. Competition's a problem for me. We like to be in an industry where we don't have a ton of competition. Down here in Tampa, Florida, it's not all that big right now as of recording this, but hey, probably just jinx myself, but that's okay. We've been here for a while. Sorry, my hair is getting long and it's getting into my ears and it's itching my ear.
You need a haircut, you dirty hippie.
Well, you know, it's hard to drive out to the guy to cut my hair, so I don't know. Maybe I'll just buzz it myself.
That's what I've been doing. You get good at it after like the first 2 times.
Oh, my mother would murder me. You did what? You can just hear her. I don't know if she listens to this podcast, but I love you, Mom. How you doing? Anyways, so that's concrete. Let's move into polyjet. And while I was there, I grabbed a polyjet sample because I have one.
Go.
Oh.
And, yep. So this is polyjet. This comes off of technically it's a Stratasys 500 Connex 3. This is actually now a kind of useless printer. There are better machines. I've had this sample for many years. The Connex 3 was capable of mixing up to 3 colors. But polyjet is similar in that it is a light reactive polymer, but it is jetted out of multiple tiny jets, hence the name polyjet.
Kind of like an inkjet printer.
It is. We're going to get to a technique that is actually an inkjet printer. But polyjet's pretty cool. It does incredibly high detail, and one side, and I don't know if you'll be able to pick it up, one side is shiny and the other side is completely matte. And that's because the side that touches the build plate and any side that touches support material is never shiny. It can't be because of the way the support material works. This technique uses a soluble support material. It comes off with a lye bath. So you use a water and lye mixture and you put in there. It is extremely caustic.
I was about to say, isn't that how you get rid of bodies?
We don't talk about those things on this podcast. That's the other podcast. Spoiler alert, we don't have another podcast. That was a joke. Don't send the feds to my house, please. But yeah, I believe use sulfuric acid, but I don't want to. I'm thinking they used sulfuric acid in Breaking Bad, or hydrochloric acid is what they used, if I remember correctly. That's actually why you should put batteries in polypropylene containers. So that's one thing you learn from Breaking Bad. It is to put car batteries, if you're storing them, in polypropylene containers, because the sulfuric acid will not eat through polypropylene. Something that Walt taught Jesse during the show. Anyways, PolyJet is really nice, but the technology is incredibly expensive. The cheapest PolyJet printers that you're going to find are going to run you $50,000 to $60,000 to start, and that's for one color. That's for black. So you can get black and gray and some of those mixtures, but that's it. Stratasys recently launched the Stratasys J850, and the J750 has been out for a while. Now we have the J850. Thomas, do you know Leica Studios?
I don't think I'm familiar.
Chad, do you know Leica?
The 2 strings?
Yep.
Yeah.
Do you know Kubo and the 2 strings, or Paranorman and the box trolls? Mm-hmm. So Leica is one of the largest users of 3D printing for a commercial purpose. Paranorman and the box trolls were made on a technology we haven't talked about yet, and that was CJP. Kubo and the 2 strings was the first time a Stratasys J750 was used outside of the medical world for an actual thing. Leica was one of the beta testers for Stratasys for the J750, because they were talking about a full color PolyJet process before they could talk about it. It was ultimately the J750. J750 is capable of 100% accurate color, as well as clear and flexible in full color. So think of a medical model. So we can 3D print a heart, but we can't 3D print a heart inside of a chest cavity that is the right squishiness, that is also clear, that has bones and veins and arteries and all that other shit. We can't do that with FDM, but you can do it with the Stratasys J750 and then now the J850. Those machines start at $430,000, have a $20,000 a year warranty package. And if you have to ask what the material costs, you probably can't afford it. But the technology, if you have a market for it, is second to one. There is one better tech out there for full color. It is by Mimaki. Mimaki came onto this planet screaming eagles, saying, hey, you know how you got to pay $500,000 to get your Stratasys? How about we give you as good, if not better quality for half the price? And the industry said, please. I assume Leica is already in bed with Stratasys, so they didn't switch over. But most companies that I know that are running full color PolyJet are running now the Mimaki printer. I don't know the name of the Mimaki printers. Look up Mimaki 3D printer. You'll find it. Editors, please add that in there for the article so people can find it. Because that's great for backlinks too. Mimaki is ranking really well. Well, HP said, well, wait a minute. We're kind of the dudes in 2D. Why don't we start playing in 3D? So HP launched their 4200, their 5200, and their 580. The 42 and 5200 are similar to an SLS machine, but instead of a laser, it is a binder jetting process. So it uses an inkjet head to lay out a dark colored binder onto white powder. They use a heat lamp that goes over it, and of course, black absorbs more energy than white because of its thermal properties. The black parts absorb a lot of heat and sinter. The white doesn't. The nice thing about HP is it is considerably faster than your standard SLS material. I actually got to see HP the day it launched. The day HP launched their 4200, it was at Rapid 2016, and I happened to be there. I was right in the front of the line, and it was a really interesting experience. We're going to talk about another tech. It's called CJP, color jet printing, and we're going to loop back to HP. So work with me here. There's technology called full color sandstone. It was kind of brought on by Z Corp Z Corp was formed out of MIT, so these machines were designed and built by MIT. And in 2011, it was bought out by 3D Systems. That's, as far as I'm concerned, when CJP died. We actually do CJP 3D printing here at 3D Musketeers. We have 3 of the machines, one of which is for sale. If you are interested in buying one of them, please reach out to us. We will have all of our information in the description down below. However, the machines are expensive. Brand new, they will cost $69,500 empty. And with enough material to run for about a month, it is $86,000 delivered for a brand new machine to your door. I know that because I have written those checks more than once. They are phenomenal machines if you keep them clean, but they actually use HP inkjet heads. They use HP C4810A black inkjet heads. And yes, they use the black head for all of their colors because that was what you did back in the day. You bought a black print head, you pulled all the ink out of it, and you filled it with the ink you needed it to be. Because, I don't know, MIT. That technology is great. It's similar to ceramic. We actually made skulls to the Smithsonian with that technology. We can maybe card to a topic about that. We got to definitely do a podcast about some of the cool customers that we've worked with since you've been on board, Tad. Thomas, of course, has only been on board with us for a little bit, so he doesn't have some. Thomas got about some cool stories that he's done. But we can maybe talk about, like when we 3D printed Snoop Dogg and Steve Aoki and Anthony Anderson and Ronda Rousey and Justin Bieber and Dan Bilzerian and Linkin Park, to name a few. Yeah, all that SEO, baby. Let's get it. Hey, you got to roll it, right? CJP, though, is brittle. And HP said we have an answer to this. HP launched the HP 580. Which is a full-color powder nylon 3D printer. Unfortunately, its color fidelity is nothing near the fidelity that you get out of the CJP machine, which is funny because HP calls themselves the king of full color. Well, you ain't the king of full color 3D printing, HP. Get your act together. We have one other contender in the full color industry. I don't even know if they're still around. I'm going to Google them and find out. Their name is MCore. Well, they're
the ones
around
that did
anymore.
the paper.
Yes.
The layered paper, yeah.
Yeah. MCore is gone.
Really?
It is now owned by Clean Green 3D.
Who knew?
Yep, they call it selective deposition lamination technology.
Yeah.
All right, I'm going to blow the lid off this thing. It's a paper 3D printer. It uses a laser printer with ink bottles. It's no different than your standard laser printer, but it's got big ass ink bottles so it can print a bunch. You take that paper, you put it into a die cutting and gluing machine where it glues, it die cuts, it glues, it die cuts over and over. Calling it a 3D printer is honestly ridiculous. Back in the day, we were looking at using either MCore, which is what it was called back then, MCore 3D, or the Z Corp 650. We got samples from both. The sample that MCore sent was absolutely gorgeous. The color fidelity was amazing, but it had a very clear and obvious layer shift where the layers did not line up. The colors didn't line up. But because it's a die cutter, the machine still cut out perfectly, but you could see a shadow was a little bit shifted over it. I'm like, well, that just lost me a $50,000 sale. Lo and behold, both machines are a bit of a pain in the ass to work with, but we have a system at least now for the Sandstone. Those machines are great if it's a part that sits on a shelf and does nothing. You can't handle them because you'll eventually start fraying the paper. The glue doesn't last very long in humid environments. And the color is not, I mean, it's okay, it's good, but it varies from how you look at it. And that was HP's biggest problem too with their 580, is that they couldn't easily get accurate color fidelity on the back and front of the parts. It was complicated. So that kind of covers our powder process. CJP is a powdered gypsum product. So actually, if you're a paleontology student, find someone that still uses CJP or powder printers. They are phenomenal places to intern because especially on the CJP side, The parts that come out of a CJP 3D printer or full color sandstone 3D printer are about as delicate as dinosaur bones. So it's a great way for you to learn how to handle that stuff without risking multi-million-year-old artifacts. That's our best interns that worked in that were paleontology interns. So it's pretty cool. And every now and then they'd come dressed up in like that stereotypical paleontology gear. I loved it. But you know, for those powder-based machines, they need their own rooms. We could not have CJP here or in this room. CJP is in another room. We couldn't have SLS in here. We couldn't have DMLS. The powder is everywhere, and it's bad for your lungs. You don't want to breathe it. So we covered PolyJet, we covered full color PolyJet, we covered CJP, we covered SLA and all those ones. We covered FDM. Let's talk about bio 3D printing. So bioprinting has been coming up ever since Grey's Anatomy showed it. Actually, Grey's Anatomy showed CJP and they called it a bio 3D printer. They were totally wrong. But bio 3D printing is becoming a thing because I can easily print a lattice of an ear and then you can paint it with stem cells. I don't care what your thoughts are about stem cells. Don't comment on it. We don't give a damn. We're talking about the science behind it, not what your beliefs are one way or the other. But you can paint stem cells on it and you can grow organs. I don't know if it's still going on. There was a trial down in Hollywood, Florida for a pancreas. This company was trying to end type 1 diabetes because pancreas transplants aren't very common. They're quite risky and they have an extremely high chance of rejection. So instead, you just kind of deal with it. You use a pump or you do insulin shots every day, and that's tough on the skin. If you could get a new pancreas, though, life could change viably for you. And that's what this company was doing. Organovo. If you do trade stocks and you want to take a look, there are a few companies that are publicly traded. Stratasys, SYSS, X1, which is, I think it's XONE is their stock one. 3D Systems, which is DDD. We have Organovo, ONVO, and that was 5, right? That should have been 5. There are 5 companies that I'm aware of that are publicly traded, and I do own shares of all of them for full disclosure, only because
of course you do.
I think it's cool. Why don't you check to see what their shares are trading at, and then, dude, I think they should all be under $10 a share right now. The market's not doing great. But Organovo makes the world premier bio 3D printer. It is $20 million. Now, a metal 3D printer runs $800 to $1.4 million. And yes, there are metal FDM 3D printers. We're not going to get into that right now because honestly, I'm not really sold on them yet. I know Markforged has one. I know that Direct Metal, a Desktop Metal has one, but meh. The Organovo printer is amazing. For $20 million, which sounds like a ton of money, but when you consider what it's capable of doing, it is cheap. Cheap like borscht. It is incredibly affordable, and especially for a hospital that sees lots of patients every year, one that deals with transplants constantly, a machine like this can be the difference between life and death for people. Now, currently, there are very few technologies in 3D printing that are approved permanently for internal use in the human body by the FDA. There have been plenty of cases where on an emergency basis it has been allowed, but biocompatibility with humans is still questionable.
I know some things like parts of certain brands of knee replacements are 3D printed. Yes,
knees and hips are the 2 big things that are 3D printed. They're made out of titanium. I hope so eventually at some point in my life, I'm going to need new knees. It's going to happen. I hope to be able to design and 3D print my own knees. Because I'm sorry, that is the best damn marketing we could ever freaking have. 3D printing company owner makes new knees. Thomas,
yeah, no, I already see the YouTube video opening up on Grant just being like, so you're probably wondering how I printed my own knees. Let me tell you about that. And then we see you print your own knees.
Well, yeah. We have like a like an unlisted video that's the surgery of putting it in, because you can bet your sweet ass everyone's wearing GoPros for that surgery.
I just wonder there's just gotta be so many walls to get through of like art, it might be allowed to get 3D printed knees, but
all the HIPAA stuff.
How are you supposed to be able to be the one that's allowed to make the? And
if we had access to that kind of technology, and they're direct metal laser centered TI-64 titanium 3D printers, they start at 800 grand. The good ones are about 1.4 million. I happen to know someone that has one, and we've always joked that if I ever need a body part, I'm coming to him.
Oh my God.
Yeah, the things we talk about. But, we've worked closely with Phoenix Children's Hospital. We've worked closely with the Mayo Clinic. We've worked closely with St. Joseph's here in Florida. And we hope to do more work for hospitals, because pre-surgery prep models are really, really cool. A great example of this and where it can be used, and it's an example that Phoenix Children's has put out, where they had a baby that was born premature that needed open heart surgery, and they needed it quick. They got a scanning fMRI. So they were able to pull out the DICOM data and get 1-for-1 accurate images of what was inside of the chest of this baby. They 3D printed it 10 times scale. So way big. But they were then able to look at, all right, how do we get in here? How do we go through so we can do what we need to do to keep this kid alive? That is huge, huge for 3D printing as far as I'm concerned. If we can start saving lives, we get less people talking about guns and we get more people talking about making awesome. It's why we named this podcast Making Awesome, because that's what this industry is all about. It's about making awesome. And is the gun cool? Okay, yeah, it's kind of cool. It's kind of cool that you can do it. Is it practical? No, it's not practical.
We've belabored this point in the past, but it will explode in your face more likely than not.
Yes.
Just because of the mechanical limits of what you're trying to do.
If you want to build a 3D printed firearm for the sole purpose of having it, it is completely legal. There's nothing that we can do to stop you from doing it. As soon as you try to put it in the hands of somebody else, you have now committed a federal crime. Be careful. Make sure you follow all the laws with the Undetectable Firearms Act of 1986 to make sure that you are not actually creating a 20-year jail sentence.
Because that would be the worst thing to 3D print.
A 20-year
jail sentence.
I don't know. Ask Cody Wilson. Oh, but you can't. Cody Wilson owns owned Defense Distributed. Defense Distributed is they are responsible for the 3D printed firearm, the Liberator. Yeah, editors, put some links to that in there too. That's going to absolutely help us rank better. But yes, is it cool? Yeah. Have we made one? Yeah, we actually made it for ABC Action News. If we can find that news clip, we'll put it up. But I'm pretty sure they deleted it because we definitely torpedoed their entire story, because they want to talk about ghost guns and I want to talk about Newtonian physics and how absurdly stupid it is to 3D print something that fires a bullet. Go build a zip gun from Home Depot. They've been around since the 60s. Don't be stupid. That's all we got to say about that topic. We're going to move on. But 3D printing is truly astounding for what you're able to do, and I still have them, whether it's trophies for a custom event that you want to do. This one is for Tampa Bay Startup Week. It was Stronger Together. Yes, Tad, I still have them because we just got the list. Did you change your thing to November? Yeah.
Yes, I did.
Okay. And this material is thermochromatic. So you can see where I was holding it. It has turned yellow. So it was a really cool thing for them to see. So, and actually we're printing the last one on that machine. So if you look, it's yellow because it's very hot. So a little bit of cool, cool tech and tidbits there for you.
We still need to make last year's, right?
Yes, we do. We still need to make last year's.
Yeah.
So that'll be something once you get some availability, we'll make it. For reference, those wondering, we did not make last year's. One of our competitors did, and they did not deliver. This is why you work with 3D Musketeers.
Crash and burn.
Because we get shit done. When we say we're going to do something, we get it done. Come hell or high water, we get it done. And sometimes we don't hit deadlines. life gets in the way. Some things have happened in my personal life in the past 3 weeks that I never saw coming and has completely thrown this business for a ringer. But like most businesses that are successful, we have a great team, and you're listening to, or you're looking at, two of the people that are integral parts of the team of 3D Musketeers that make it happen. And because we have these kind of talks with with each other constantly, we decided, oh, what the hell, let's do a podcast. And now everybody's got good audio. We're getting Tad some better lighting. He's got good lighting, but his backdrop, similar to mine, has got a lot of natural light, so it backlights you. Like if I back up even a little bit, it gets really rough. But, that's just part of making things happen. And, 3D printing is a really cool subject because there is so much out there. And that's the tech that I'm aware of. And I'm sure there's stuff that we've missed. Whether there's subsets like a pellet 3D printer that uses, they use, instead of filament, they use the raw pellets, and they actually extrude material from that. There's Bailey again.
Bailey, you sad animal. Why are you
She's
so
our
sad?
guest for today. Special guest
She's
Bailey.
Guest. Come here, Bailey.
But yeah, pellet 3D printers are great because you can do crazy thick layers with them, and be able to get really cool parts, but your resolution is lower. And you're going to see a lot of cool things coming out of us. I think next week we should have all the branding done for this podcast. Here's hoping. If not, oh well. You'll see it whenever we see it. So next week, for a little insight, might be the update on all of our branding, because we should have had all of our branding done. Or it's going to be, we're going to have our first special guest. That's going to be a really cool story. A story that is, well, I'll tell you, don't be cutting onions when you're listening to the story, because you might think you are. Anyways, God, I feel like I just kind of overran the whole podcast, which is upsetting.
No, well, you have the most knowledge of the three of us, and I think you did a pretty thorough breakdown,
And
I wouldn't
I'm
worry
thinking to
about
myself, what did I miss? What did I miss? What did I miss? This is all that I'm thinking. I'm like, all right, I'm going through all the text that I'm aware of, right? And, you'd be surprised how much stuff is 3D printed in your day-to-day life, or stuff that started 3D printing. If you have a Ford, I promise you, almost every single part in your Ford was at one point 3D printed.
Mm-hmm.
Nissan is the same way.
If only in the prototype phase, but even some production parts are 3D printed.
Yeah. Actually, a 3D printed part caused a big recall for Ford. They were 3D printing the intake manifolds for, I think it was either the 5.0 or the V6 Mustang. And they had a tendency to break. That's not fun. Not fun one bit. And so, Thomas, you don't have too much experience then with 3D printing, other than that weird pug bird statue thing that is the creature of nightmares.
Yeah, I mean, aside from creatures of nightmares, my 3D printing knowledge is not a lot. I mean, I've actually used it a few times before in projects for design things, but otherwise, not myself personally.
Well, we hope to be changing that here pretty soon. I'm excited because it's always fun. Like I've gotten to see Tad's maturity in this industry, and I've seen him kind of be interested in it. He had some experience with it, but he didn't own his own machine yet.
Mm-hmm.
He used it at work, but didn't own his own machine yet. I mean, geez, you've worked with this for almost
really
3
was
years,
like
right?
To jump off of a cliff, sort of. I took the plunge after getting my own, and that really,
And you know what?
boosted.
Let's hit that topic. Talk to us about your experience with that printer. And I know that we've talked about it before, like the cost of 3D printing, but they might not have watched that or listened to it. So talk about your experience with lower grade machines, with this machine, with higher grade machines, and your experience.
So like I said earlier, I started out in college with some very, very low quality printers that were just a bear and a half to maintain and get to work. And I didn't really do much in between. There's a printer at my work that does not get much use. I think they were trying to like, use up a budget so that they'd get the same amount the next half or something. And I printed something on that just to say that I could. But I was like, I need to get one because I've been meaning to for the better part of a decade. And finally I did. The Prusa that I got, MK3S, it cost 800 shipped, which is not so bad for a printer of its quality. You can pay $1,000 and get it delivered fully assembled, but
unless you are a business, do not do that. Buy the kit.
No.
You want to learn it. Okay.
Exactly.
And I'll do that. I think I did it back then too. I will hold up the instruction manual. It is the better part of 300 pages, full color with great details. I mean, this is what manuals for everything should look like. And I literally keep one near me. So when people ask about 3D printing, we can talk about it because there are cheaper options out there. You can look at an A8, which is a house fire. You can look at an Ender 3, which is going to be a nightmare. Ender 3 is not really a house fire, but it's not going to be a great experience because the Prusa to me is that right amount of time versus money. If you spend very little money, you will spend a lot of time. If you spend a lot of money, you should viably spend a little bit of time. We have our big Fusion 3. It is a $5,000. It's just under $5,000. I think Chip would kill me if I said it was $5,000. It's just under $5,000. That is a machine that we do resell at 3D Musketeers. So if you're interested in getting a machine that you don't need to touch, Fusion 3 is actually pretty good. That machine I can basically click print and walk away from. Same thing with the Prusa Mark 3S, but Prusa does not have a warranty like Fusion 3 does. And I think that's a lot of the expense on Fusion 3 is their technical support and their warranty.
Because it's pretty good.
It is. And Prusa has phenomenal technical support too, but their warranty of only 1 year. And they're starting to get a little touchier with that because a lot of problems that people get with Prusa printers are their own damn fault. It's not Prusa's fault. Like, don't get me wrong.
The materials and the workmanship are good.
Right. One of our machines came with a bad Pinda probe, which is the probe that it uses to figure out its auto bed leveling. Prusa had one to me in 2 days. I overnighted one from Amazon because I was lazy. But because Prusa is open source, we can easily do that kind of thing where I can just buy parts on Amazon. Bed thermistors for Prusa. Dude, I got like 10 of them here. And then since it is, of course, open source, here are the correct connectors. And I can make my own pinouts and connectors. That's easy. So, yeah, I mean, that's the deal.
Yeah.
Look, if you are out in the market to buy a 3D printer, please contact 3D Musketeers or the Making Awesome podcast first. We'd love to have you on as a guest. Tell us about your story about 3D printing and why you decided you want to get one. We want to go through with you why you've chosen the machine you want to choose and discuss the reasons for it. Because I think you'll find that even if you made $10, let's say you paid yourself $10 an hour, a Ender 3 is going to quickly become more expensive than a Prusa because of all the mods you have to do. A Prusa, the mods that we do to our printers are to make quality of life better. It makes like tuning it a little bit easier. It does not change anything about the performance of the machine. With an Ender 3, you need to change things that adjust the performance of the machine, and that's a problem.
That means the design is not good.
Right. And, you know, when a machine is built at $200 and it has heaters, little tiny cartridge heaters. I have one right here. Little tiny cartridge heater that is maybe 20 millimeters by 6 millimeters. That produces 40 watts worth of heat. This thing will melt anything it comes in contact with if it runs away. That's a problem. So remember, when you're looking at a 3D printer, just because it's cheap doesn't mean it's great. If you have questions, reach out to us. It doesn't cost a dime to pick up that phone. Give us a call. A little Wolf of Wall Street there for you. Pick up the phone, make some money. But yeah, that's really all I got. I mean, this was what is 3D printing. Making Awesome, supported by 3D Musketeers. Anything else before we get out of here, gents?
Not for me. I think we covered it.
Yeah, that felt pretty good to me. I feel like I learned a lot, so that's good.
Well, good. Like I should have done. I should have said, all right, Thomas, did I explain things in a way that you can understand them, or is a lot of it over the head? Because of course, for those of you that don't know, we're going to be launching a learning management system. And look at that. I have just put myself in a position where I have to actually do this now. Where we're going to teach you about all this stuff in detail so you can learn. There's going to be a maker track where you can learn about how to use a 3D printer and common problems. Because screw it, I go through all this crap anyways. I might as well teach other people how to do it too. And I'm giving away all my knowledge on Reddit. We might as well start charging for it, right? But yeah, I mean, there's so much out there. What we tell people is there are two limiting factors in this industry: your imagination and your budget. That is it. That are the only two things that will limit you in what we are capable of doing. And I guess your education, right? So whether or not you understand this stuff. And that's why we're doing the podcast. The podcast serves currently as a means of education. And eventually it's going to turn into us interviewing makers and going through them on how to make awesome. I've actually also secured another guest. Her name, well, I guess her stage name, the name that everyone knows her by, is Billy Rubin. And if you look up Billy Rubin, she suffered from a Billy Rubin deficiency when she was a child. I'm sure she'll tell us all about this, but she is a maker in Australia. So that one might be tough to schedule, but we'll figure it out. Anyways, this has been fun. I'm glad that we re-recorded this, because I think as a solo, it is kind of the same stuff, but I think
it's better when the three of us can contribute.
Right. And it's not just me talking to a camera. And I think back then it was my 720p camera. Now you can see my true face for radio if you are watching us on YouTube. But please, if you are listening to us on iTunes, leave us a review, 5 stars only. Look, if you don't like it, just email us. You can cuss me out an email. Don't cuss us out on the reviews, because honestly, that really hurts us. It hurts our ability to grow. Subscribe to us, share us with your friends that you think would think this stuff is cool, or your friends that don't know enough about it and you want to talk to them about it. This podcast is here to help others get inspired. It's help people that are stuck in a rut to get out of it and get things done. This is Making Awesome. My name is Grant. We have Tad and Thomas here. Thank you all very much for joining us. Take care. And remember, you can visit us at 3dmusketeers.com/podcast, where you can currently apply for free to be a guest on this podcast. As always, keep making awesome. Have a great day.